Experiment number 7, verification of DFT properties. Here we are going to verify three different properties of DFT. First one is the linear property, second one is Parseval's theorem, third one is circular convolution in time domain is same as multiplication in frequency domain. So first we will move to the first property, linear property. What it says is that if x of n is the DFT of, if x of k is the DFT of x of n, x2 of k is an DFT of x2 of n, then DFT of the sum of these two signals or sequences is equals to the individual sum of their DFTs. So algorithm is like this. We have to input the two sequences, add those two sequences and calculate the DFT of the result, then calculate the DFT of both the sequences individually and then add the result. Then obtain the given sequence by using FFT command and verify the linear property of the DFT. So this is the linear property. The second one is Parseval's theorem. So it says that the summation from n is equal to 0 to n minus 1 x of n and y conjugate of n is equals to 1 by n summation from n is equal to 0 to n minus 1 x of k multiplied with y conjugate of k. So this equation gives energy of the finite duration sequence in terms of its frequency component. So the algorithm is like this. So input the two sequences x and y, calculate the sum of the product of x with conjugate y, then obtain the DFT of the sequence using FFT command and obtain the DFT of x and y sequences separately and then take the conjugate of y. Later calculate the sum of the product of this x and conjugate of y. Then divide the result by the length of sequence, that is capital N. Thus verify the Parseval's theorem of DFT for the resultants. The next third property is the circular convolution in time domain is equal to the multiplication in frequency domain. So it states that if x of k, x1 of k is the DFT of x1 of x, x2 of k is the DFT of x2 of n, then circular convolution of x1 of t, x1 of n and x2 of n is equals to x of k multiplied with x2 of k. Okay, so this is the circular convolution. So the algorithm is like this. Input the two sequences x and z, define circular convolution function and obtain the convolution of the two sequences using CIRC command. Then calculate the DFT of the sequences x and y individually and compute the product of DFT of x and z and then take conjugate of that result. Then calculate the IDFT of the resultant and verify the result. So when you open the Scilab, so the program is like this. This program explains you the linearity property. So here we are assigning the sequences x and y and z gives you the x plus y. Then to this we have to apply the FFT. We have to take the DFT using an FFT command and display the result. Later we have to apply the FFT to both the sequences separately and then later add it and display the result. And if both are same, it will display linear property of the DFT is verified. So if both are equal, then linear property of DFT is verified. So save and execute it. So in the we don't have any graph over here. So in the console window you can see. So both the sequences are same. So the linear property of DFT is verified. So similarly the second one, Parseval's theorem. So here x and y are defined. So h is what? The sum of this x and the conjugate of y. Okay. Then display this h. Then take the n which is the maximum length of x as well as the y. Then individually calculate the FFT of x and y. Then take the conjugate of y. Then later take that z is equal to sum of this x with the conjugate of y1 and divide it by n. Then you have to display the z. So if z is equals to h, then the Parseval's theorem of DFT is verified. Save it and execute. So in the console window you will see that 17 is equal to 17. Thus the Parseval's theorem is verified. So you can try this one for different values of sequences x and y. So you can make it as an user defined. Okay. Then comes DFT. Circular convolution in time domain is equal to the multiplication in frequency domain. So here first we have to define the function called circular convolution. So that is defined taking the maximum length of x1 and x2, and within the for loop we are incrementing it from n is equal to 0 to n minus 1 and m is equal to 0 to n minus 1, and the I is calculated of Pm modulo of n minus m comma n until and unless if I is less than 0, then the I gets incremented, and later y of n plus 1 is equal to y of n plus 1 plus. So here x1 of m plus 1 multiplied with x2 of I plus j. So for x is for the different values of m, and this x2 is for the different values of I. Okay, so this is what the function of circular convolution. So let us end that function and then define the x and z2 sequences, then calculate the circular convolution using a command CIRC. So then later calculate x is equal to FFT of small x, that is finding out the DFT of these two sequences x and z, and later dot product of this both is calculated, and applying an inverse FFT you will get a small a. So then you have to display that result. So that gives you the circular display. So if both this a is equals to the if a is equals to this y, then you can say the circular convolution in time domain is same as multiplication in the frequency domain. So save it and execute. So you can see the result in the console window where you have the same sequence in when it is convoluted in time domain as well as multiplied in the frequency domain. And this completes the experiment. Thank you.